complex fraction has an unfortunate name. First of all, it has the word complex in it. Second, everyone hates fractions. But what it really means is it's a fraction that has more than one numerator and or denominator. And so you can see that present in the two examples in front of us. But the way we kind of have to look at this is really it's a division of question where we're just dividing two fractions. So we could rewrite this in a horizontal rather than stacked vertical format. So we'd say it's 8 over 2x divided by the fraction that's on the bottom, 12 over x squared. And so then once we see it like this is a far less intimidating problem. What we have is just a division question, and we know that to divide fractions, we just multiply by the reciprocal of the second fraction. So I'm going to leave this first one as 8 over 2x, and I'm going to make it a multiplication question, so times x squared over 12. And so now once I have it rewritten as a multiplication question, I can start reducing anything that I can. So I can see there's a 2 on the bottom, can divide with the 8 to leave me with a 4. And then if I stay with the numbers, the 4 can divide into the 12 to leave me with a 3 down here. So that finishes off the numbers. And then with the variables, I can see I have an x on the bottom here and an x squared on the top. So that'll reduce this down to a 1 exponent. So in the end, out of all of this, we have just a single x in the numerator and then just the 3 in the denominator. So our answer is just x over 3. In the second example, same idea. We have the top fraction divided by the bottom fraction. So we've got x plus 5 over 5 that's being divided by that second fraction, x squared minus 25 over 25x. So now we're ready to go ahead and change this to a multiplication question. So again, this first fraction stays put, x plus 5 over 5, and then I'm going to flip this second fraction as I change it to multiplication. But at the same time that I do this, I'm going to go ahead, first of all, the 25x ends up top, but I'm also going to factor. So this x squared minus 25 that I have in the top is going to factor into x plus 5 times x minus 5. So I've basically done two things at once. I flipped the fraction because I changed the problem to multiplication, but then I've also factored that x squared minus 25 into x plus 5 times x minus 5. And so now that we're in this stage, we're ready to do our reducing. So I can see a 5 here, and the 25x will reduce away down to a 5x up top. Then I've got an x plus 5 can cancel out with the x plus 5 that we have here. And so then in the numerator, out of all of this, we can see we have 5 times x, so 5x. In the denominator, we have this x minus 5. And as we've talked about many times, because in the bottom, the x and the 5 are connected by subtraction, there's no other reducing that we can do. This is the best that we can get. So one more time, we'll rewrite this in a horizontal format with the top fraction divided by the bottom fraction. And then we have a bunch of factoring to do. So we have 8x squared minus 72 over 5x plus 10. And then that's going to be divided by 4x minus 12 over 5x. So now let's start our factoring. So the first fraction here, we can, in the numerator, we can undistribute an 8. So we take out an 8. That leaves us with x squared minus 9, which hopefully we see we'll be able to factor further, but we'll get there in a minute. And then in the denominator, between the 5x and the 10, there's a 5 that's in common, so we can undistribute that, and then we get x plus 2. And then I'm going to go ahead and flip this second fraction as I change this to a multiplication question. So I'm times the 5x is now going to be in the numerator, and then I'm going to, like I did on the previous question, factor as I flip it. So the numerator here, I can see that there's a 4 that's in common, and then I can factor that out, the 4, leaving me with x minus 3. So I do have one more little piece of factoring that I can do, which is this x squared minus 9. So I've got 8 times, that's a difference of squares, so it's going to factor into x plus 3 times x minus 3. But now everything else is fully factored. So I have this 5 times x plus 2, and then times 5x over 4 times x minus 3. And so now my cross-canceling fiesta can begin. I can see that I've got an x minus 3 on the top and the bottom. I've got a 5 here and a 5 connected to the x, but it's all connected by multiplication, so those can go. And then as tempting as this 2 and the 8 might be, that 2 is connected by addition to the x, so I can't reduce that. But I do have the 4 and the 8 that I can reduce, so the 8 turns into a 2 there. But that looks like I have exhausted everything. So up in the top, just don't want to lose track of anything. I've got this 2, this x plus 3, and this x. So I can write that as 2 times x plus 3 if I order it like that. And then that's all over. The only thing left in the bottom is this x plus 2. So we'll leave that there. And so then that's the best that we can do in reducing that expression.